In this video, we'll look at equations of lines and how to graph them using a table of values. The equation of a line is a linear equation in two variables. Linear means that the exponent on each of the variables is equal to 1. Here are two examples. Notice that these equations have two variables and that the exponents on these variables are all equal to 1. Because there are two variables in these equations, a solution will have to have two values, one for x and one for y. We write those as ordered pairs, with the x value first and the y value second. Here are three ordered pairs that are solutions to the first equation. For any of these ordered pairs, if we substitute the first value for x and the second value for y, we'll get a true statement. When x is equal to 0 and y is equal to -4, we get 0 minus 2 times -4, and a -2 times -4 is equal to +8. So this ordered pair is a solution. And you can check the other two ordered pairs in the same way. When x is equal to 10 and y is equal to 1, we get 10 minus 2 times 1, or 10 minus 2 is equal to 8. Let's look at what happens when we graph these ordered pairs in a rectangular coordinate system. Here's the graph of the three ordered pairs. And notice that they all fall on a straight line. That will be the case for any linear equation in two variables. And in fact, any ordered pair on this line will be a solution to this equation. So how do we find these solutions? How do we come up with these ordered pairs in order to sketch the graph of a line? One technique is to make a table of values. To graph a line using a table of values, we use a table with two columns, one for the x values, one for the y values. And we can pick any number for one of the two variables and then solve for the other variable. So in this first row, we're going to start with an x value of 4, and then we'll solve for y to complete an ordered pair. In the second row, we'll start with a y value of 0, and then solve for x to complete an ordered pair. And then the same thing in the third row with an x value of -2. We can choose any number we want for x or y, and then solve for the other variable. So let's start with the first ordered pair, where we're going to have x equal to 4. We're going to substitute this value for the variable x in this equation. And that gives us 4 minus 2y is equal to 8. And we can solve for y by isolating the variable. So first we'll subtract 4 from both sides. That leaves us with -2y on the left side and +4 on the right side. Now we can divide both sides by -2 to isolate y. And now we have y is equal to -2. That means for this line, when we have an x-coordinate of 4, we have to have a y-coordinate of -2. So that gives us our first ordered pair. Now for the second ordered pair, we'll substitute y equals 0 into this equation. So we have x minus 2 times 0 is equal to 8. 2 times 0 is equal to 0. So we have x minus 0 is equal to 8, or just x is equal to 8. That means that on this line, when we have an ordered pair with y equals 0, the x-coordinate must be equal to 8. And that gives us our second ordered pair. And for the third ordered pair, we'll start with x equal -2 and substitute that into the equation. Now we'll isolate the variable y, so we want to cancel this -2 by adding +2 to both sides. And now we'll divide by -2 on both sides to isolate y. And that leaves us with y is equal to 10 divided by -2, which is -5. So when x is equal to -2, y must be equal to -5. And that gives us our third ordered pair. Now to graph the line, we just plot the ordered pairs from this table and draw the line that passes through them. So here's the graph of the line that we get from this linear equation with two variables. You really only need two ordered pairs to graph a line because only one straight line will pass through 2 points. But it can be helpful to find a third ordered pair just to make sure that all three of them are correct. This is actually the same line that we were looking at before. I just used some new values for x and y so we can get different ordered pairs and show you how to construct a table of values. Here was that line, and the three ordered pairs that we found in our table all fall on this line. Here's 8, 0. Here's the point 4, -2. And over here we have -2, -5. Let's look at another example. In this example, notice we still have two variables, and each has an exponent of 1. So this is a linear equation in two variables. In this case, the y variable has been isolated on the left, but we can make a table of values the same way that we did in the last example. In this form, however, it's usually easier to pick numbers to plug in for x, because then all we have to do is evaluate the right side of this to get y. So here I've chosen 3 x values, and we're going to plug those in and evaluate this to find the y that goes with each of these. Notice that because I have a fraction here as the coefficient of x, I've chosen values for x that will cancel this denominator of 4. Any multiple of 4 that you plug in for x will cancel out this denominator and leave a nice whole number for y. We'll actually start with x equals 0, which eliminates this entire term and will leave us with y is equal to 2. So when x is equal to 0, we get y must be equal to 2. Now we'll substitute an x value of -4. So we have y is equal to -3/4 times -4 plus 2. This 4 will cancel with the 4 in the denominator. If it helps, you can write this as -4 over 1. But either way, the 4's will cancel, and we'll be left with -3 times -1 plus 2. Don't forget about the negative on this 4. So we have y is equal to -3 times -1 plus 2, which is +3 plus 2, or 5. So when x is equal to -4, y must be equal to 5. And for the third ordered pair, we're substituting an x value of 4. Again, this 4 will cancel with the 4 in the denominator. This time, since we started with a +4, we're just left with a 1 here. So we have -3 times 1 plus 2. -3 times 1 is -3, plus 2 is equal to -1. When x is equal to 4, y must be equal to -1. Again, we have three ordered pairs. We'll plot those points and sketch the line that passes through them. So here's the line passing through those three ordered pairs. Feel free to use graph paper and a ruler when you're sketching the graphs of these lines if it makes it easier. Let's look at one last example. In this example, we're asked to sketch the graph of this line using a table of values, but we're not given any values in the table to start with, so we'll have to pick our own. Remember, we can pick any number we want for either of the two variables. Usually we'll want to pick smaller values because that'll make it easier to plug in and solve. In fact, it's usually easiest if we plug in 0 for x or for y. So let's start with an x value of 0 in the first row and a y value of 0 in the second row. And then we'll need to pick a different number to plug in for either x or y for the third row. Why don't we use an x value of 1? Now we can complete this table. Let's start with the first ordered pair and substitute an x value of 0. Using a value of 0 is nice because that term disappears and we're just left with 2y is equal to 10. Now we divide by 2 on both sides to isolate y, and we're left with y is equal to 5. So when x is equal to 0, y must be equal to 5. And that gives us our first ordered pair. Next, we'll plug in a y value of 0. Again, substituting a value of 0 makes that term disappear. So here we're just left with 5x is equal to 10. And now we'll divide by 5 on both sides to isolate x. So when y is equal to 0, x must be equal to 2, and that gives us a second ordered pair. Finally, we'll substitute an x value of 1. This will give us 5 times 1, or 5, plus 2y is equal to 10. And then we'll subtract 5 from both sides. And now we can finish isolating the variable by dividing both sides by this coefficient of 2. So when x is equal to 1, y must be equal to 5 halves. This time we got a fraction, and that's okay. That's pretty common. We'll treat this 5 halves as 2.5 and plot the ordered pair like we would any other ordered pair. Here are the first two ordered pairs, 0, 5 and 2, 0. For the third ordered pair, we'll have x is equal to 1 and y is equal to 5 halves, or 2.5. So here we have x equal to 1 and y equal to 5 halves, or 2.5, will be here between 2 and 3. And now we have the graph of the line.